Hi there, this is Namju. You can call me NJ because it's easy to memorize. I am a founder of NJ Studio since 2004, specializing in computation visualization. I'm very interested in the data in terms of developing the design process because the data has a lot of insight, and actually it's very fun to process the data to set up a design process. So today I'm going to talk a little bit about my interest and my projects. Hopefully it helps you to communicate my understanding of the data and design process with you guys. I mean, everyone has their own sort of definition and understanding of the design process and each jargon or term, right? But my understanding of the data is basically everywhere. Every time you design, every time you communicate with other people in daily life, you keep producing the data and process internally. I mean, explicit way or implicit way, right? So particularly, I have 3 topics to discuss today. The first one is data, ranging from product level to urban scale. The second topic is about the methodology to compute, to process the data. The last one is how we cook the methodology based on your purpose, like I'm going to design facade, or I'm going to design some urban area, or I'm going to analysis this particular area. I mean, it's basically process. So I think we can call it something like system. Yeah. So in the big umbrella, we can think about this is a sort of a computational design or numerical design or parametric or algorithmic. I mean, it depends on your purpose. Which one do you want to emphasize? Why you use computational methodology to develop your idea or to process your design data? Sometimes people use computational design for optimization or fabrication or generative design. So my definition of the computation design is basically process data, and then we can extract or review some insight that possibly help us to make some design decision, right? So before we actually start, I want to ask you guys, what is data? Yeah. I mean, there's a lot of definition in different domains, like in computer science, people think about, data is a numeric number, or some string, or some structured information. I mean, there's a lot of sort of interpretation. But my understanding of data in this context, something you can actually aware of it. In case that you can translate phenomena or some behavior or some, some geometry or whatever as numeric number to be computed. So we can actually consider this as data for your design. I don't need to talk about this topic deeply because this is a very well-defined term. But the point I want to make in this context is, in case that you can recognize something, we can consider it as a data. So just think about, so architecture is basically dealing with some shapes or 3D geometry. So geometry, which is data, or our environment like temperature, wind speed, and sunlight or shadowness. We can also consider they are data. So what else we have? Population or economic information. We are human beings, so emotional also become data. I think the interaction is also data, and material is also data, right? I think you got my point, right? I guess more refined term is data, or we can find data at different scale, like geometry, architecture, urban landscape, or material or fabrication or building energy, whatever. As long as you detect, as long as you recognize, you can process them and use them for your design process or decision making process, okay? So in computer science, basically they're dealing with data, right? Because their primary job is to create the program to process data, right? So what I'm trying to say is that, the importance of the data structure is become crucial. There are different types of data structure in a conventional way, or you can customize your own data structure. But particularly, we are dealing with the spatial information, right? Because I'm architectural designer, you are urban designer, you are landscape designer. We basically dealing with all spatial information, right? So what I want to talk about is the data structure for process spatial information. How we process the spatial information, right? Such as graph, or 2D matrix, or 3D tensors, things like that. Let me summarize a little bit. So now we have data, and then we have a data structure to process this data, right? And then we basically orchestra and then make some recipe to cook this data structure with data. So we can start thinking about something like system. I mean, I'm work as a software engineer myself. So basically, most of my job is to create the pipeline or architecture, not like architecture, it's like a software architecture. So basically, we have a data is like continuous flow based on the interaction or some input or some other functions to trigger the pipeline. And then pipeline is basically switch the data structure to process the data. So, but in terms of the design, we have a better term like design process. So my understanding and definition of computational design is more about to think about how we translate the design process as a computational pipeline. So we can say this kind of thing is a system for design. So such as optimization or automation or agent-based design system, rule-based or generative design or data-driven design, or like setting up complex system in design. Let me summarize before we're looking at some example or research projects, okay? So as a primary resources, as long as you detect, we can consider this is data based on your purpose or your design process. We can deploy data structure to process the data. And also, we can package them as a system. So inside of the system, there's a lot of the data structure and functions and computation to cook the data, okay? It's like a restaurant, yeah? So we have like vegetable and meat based on the menu in your restaurant. Actually, we have our own recipe, right? So computation design is just, run your restaurant. I think this is a good example. Now we can see what is data and how to cook the data in design process.